So in this problem, we're asked to find the exact area of the region that's bounded by the x-axis and this function, okay? And so to find area under a curve, we can use an integral, right? But one thing we need to know is what are the limits of integration? What do we need to integrate from and to? So we need to get a visualization of what this graph looks like so that we can find the area that, or visualize what this area bounded by the x-axis on this graph looks like. So I'm just going to sketch a little graph of this thing. Now, one thing I know, if I multiplied this out, I would have a quadratic, right? Because I'd have an x, I'd have an x squared term plus some x term and so on. So I might want to multiply this out, but I also kind of like it in this factored form because if I set it equal to 0, then I know I have x-intercepts at -3 and +1. Okay, so I'm going to actually draw my axis here, and I'm going to put 1 over here, -1, -2, and then let's put -3 here. Okay, so I'm going to have x-intercepts at -3 and +1. Okay, if I sketch that graph. Now I also know because of this negative outside here is that it's going to be a parabola that's facing downward, okay? And it's going to have a vertex halfway in between these two x-intercepts. So halfway in between is -1. And if I evaluate this function at -1, if I call this, say, f of x equals y, then f at -1 is going to be -1 plus 3 is 2, and then times -2, so and then times -5, so I get a +20. Okay, now my scale, I have to use a different scale on my y-axis, but let's just say this is 20. Okay, and so we're gonna have a vertex here, if that's so here at -1 comma 20. All right, and then it's going to be facing down from there. So my graph looks something like this. Now, it's going to keep going here. And we want the area that's bounded. Bounding means it has boundaries, right? So we want the area bounded by the x-axis and this graph. So the area that we're talking about is this area right here. Okay, and so if we integrate from -3 to 1, and we integrate this formula, this function here, then we'll have the area. Now, so I want to integrate this function, and it's a lot easier to integrate if I write it as a polynomial. So if I, let's multiply this thing out. So if I multiply by 3x, x plus 3 times x minus 1, I end up with x squared, and then I have 3x minus 1x, so that's 2x. And then I have -1 times 3, which gives me -3. And then I can multiply through by the -5. I wouldn't have to. I could actually leave it out on the outside. Yeah, maybe I'll just I'll just do it this way since that's the way I did it on my paper. But okay, so we have -5x squared minus 10x and plus 15. So that'll be easier to integrate. All right, so we want to do the integral from -3 to 1 of this polynomial -5x squared plus, whoops, not plus, minus 10x plus 15 dx. Okay, so we're just going to use the reverse power rule. Okay, so we need the antiderivative, right? So we're going to evaluate the antiderivative, and I'm going to put it in square brackets. So this gives us -5 times x cubed over 3, and then -10 times x squared over 2, and then plus 15x. That's the antiderivative. I could put a plus c, but I don't really need it because it's a definite integral, so the c's will go away. So, and then I'm going to evaluate that from -3 to 1. All right, so we're going to use the fundamental theorem of calculus, and we're going to evaluate the antiderivative at those 2 points, f of 1 minus f of -3. All right, so let's start with f at 1. We get minus 5/3. And then when I plug in 1 to the second term, I get minus 10 over 2, so that's just minus 5. And then plus 15. Okay, and then I'm going to subtract the antiderivative evaluated at negative 3. Okay, so I have to be careful with sign errors here because they just write it out carefully and you won't have trouble, but it's really easy to make a sign error here. Okay, so we have minus 5, and then we have minus 3 cubed over 3. Okay, and then we have, I'm just going to write it as minus 5, and then we have minus 3 squared. And then we have plus 15 times minus 3, which gives me I'll just write it as plus a negative 45. Okay. All right, we got to get the exact answer. So, I mean, I could just put this in my calculator, but I get a decimal. So if you want an exact answer, we got to do the arithmetic. Got to remember how to work with fractions and all that. So I'm just going to kind of slowly take this and simplify it. So I'm going to just leave the minus 5/3 alone. I can combine the whole numbers, so I get plus 10. And then here, one of these 3's will cancel. I got to remember 3 cubed is negative, so I'm just going to make it, this is going to end up being minus 9, right? When I cancel one of the negative 3's, so I'm canceling a negative 3 with a positive 3, so it's still negative, so that's going to be a minus 9. And so, let's see, we have minus, a minus, a minus, so we have minus 45, okay? And then we got this term, when we square the negative 3 here, we get a positive 9, though. Okay, so this becomes a negative 45, but then we're subtracting it, so this becomes plus 45, right? And then here we have minus a minus 45, so that becomes plus 45. Okay, that's good. We can cancel one of these 45s, these two 45s. That makes it a little simpler. So basically we have 10 plus 45 is 55, and then minus 5/3. Okay, so if I work that out, I end up with 160 thirds. So if you want it as a improper fraction, there you go. You could write it as a mixed number. Generally, in algebra, I don't really like mixed numbers, but you know, we could also say 53 1/3. Okay, would be another appropriate answer. So there you go.